Hey everyone. So we're going to look at an example using weddings. We want to be able to analyze the relationship between wedding cost and some other factors, such as the couple's income, whether or not the parents are paying for it, bride's age, things like that. And then we want to go ahead and predict wedding cost or create a prediction model based on this sample of 25 weddings. So let's take a look. We have our sample of 25 weddings, each with a cost, couple's income, bride's age, the payer, attendance, and value rating. So let's look at the data as a whole. We know we want to predict wedding cost. So let's go ahead and put this over here so that we can separate our X and Y variables. So I'm going to delete that. And now we have our X's on the left and our Y's on the right. Okay, now we also see that this data is categorical. We want to encode it so that it is numerical, and that'll allow us to better analyze the data when we create our prediction model and when we try to discover the relationship between wedding cost and payer. So there's two ways to do this. We can go to Find and Select right here, and I'm using a Mac, so the interface might be a little different. So we'll replace, we'll start with bride's parents, and we have to be careful with case, and we're going to make that 0. All right, and let me show you the second method of encoding. So on my keyboard, I press Control or Command F, and right here this comes up. I want to click right next to the magnifying glass and press Replace. So now we're back to the same screen we had before. Now we'll encode bride and groom as the numerical value 1. And then we have one more, which is groom's parents. Groom's parents. And we'll replace that with a 2. Usually when you're encoding variables, you want to start with 0 and then go up to the amount of options that are within that variable. So in this case, there are 3 options, so we'll have 0, 1, and 2 as our encoded numbers. Now, before we get into trying to create a prediction model using multiple regression, we might want to take a look at the relationship between wedding costs and one variable. And let's keep it straightforward with attendance. We already know logically that if the attendance at a wedding increases, it's likely going to cost more. So we already have an idea of what that relationship is going to look like. So I'm going to copy and paste wedding cost and attendance into a new sheet. And when you're doing this, in order for Excel to pick up the correct X and Y values when you're creating your visual, you want to put the X value on the left and the Y value on the right. And you'll see how this turns into a very nice scatter plot. Here it is. So we have our Y value, which is wedding costs, and it is also the title because this is what we are measuring based on the attendance, which is our independent variable, or X. Now we don't need to worry too much about axis labels, but we do want to add the chart element of a trend line, and we'll add a linear trend line. And then we can play around with this trend line. I just double-clicked it, and we can display the equation and the r-squared value. And let's take a minute to look at what these mean. So your Y value is telling you, if we remember from algebra class, Y equals mx plus b. So y equals the slope times x plus the intercept. So in this case, y equals 130.12, which is our slope, and then x, which is the attendance, plus 1,905.7. So in general, for every 1 unit of increase in x, y increases by the slope, or y increases by $130.12. So what does this mean practically? It means that, okay, if there are no people or no persons in attendance for a wedding, it's still going to cost $1,905. Now, for every person that you add to your wedding list, it's going to cost you an additional $130.12. And so this is an average based on the sample we just created here. So the R-squared value tells you how closely these particular data points fit the linear trendline model that we see on top here. So in other words, it's saying how well this line can predict the points within this sample, based on this sample. And a way to phrase it is, this linear trend line is a fit to this data set to a degree of about 53%. And the reason we can say 53% is because R-squared is always between 0 and 1. Now let's be a little bit ambitious and try to forecast using this linear trend line. Now usually when we're forecasting, our x value is time-based. And in this case, it's not necessarily time-based, but we can still forecast. And our forecast would be predicting the wedding cost using values outside of the attendance variable that we see here. So for example, we'd be forecasting over an attendance size of maybe 500, 600, 700 people. So let's take a look at how that's done. I double-click the trend line, and I have forecast right here on the bottom. I want to forecast over maybe 200 periods. So this represents 200 more people. All right, based on this trend line, if you had a wedding of about 500 people, it would be kind of on the upside of $60,000. And this number, 500, is not within our sample of attendance, but we can forecast and predict values outside of what is in the scope of our sample. So one more thing we can do with this data set is actually run a regression analysis to compare these two variables, and this will help us have a better point of reference for when we do a multiple regression on the original data set. So we can go to data analysis, and I'm going to run regression. The y is what we're trying to predict, so that is wedding cost. The x is the factor used to predict wedding cost, which is also the independent variable. And we're going to not have any of these checked. We're going to put the output here. All right. So this is what we have for the regression analysis. So let's take a look at what each of these are telling us. We have our R-squared, which is the exact same R-squared that we see here on the linear trend line. So this is telling you the relationship or the fit of this data set to the linear trend line that we created. The standard error is the average distance of each data point to the linear trend line. And then we have our significant F and our F test. And another key point is the t-stat and the p-value. So we're going to get into that a little bit later when we look at the multiple regression.